This is Euclid Book 3, proposition number 11. And we have two circles. One super humongous, which starts at point A, goes to point C, and comes all the way over here, point B, and comes all the way back around. So you got one giant circle. Inside the giant circle is another smaller circle, and it starts at point A, it goes to point E, and it comes all the way back up here to D. Alright, now it just so happens that the smaller circle and the bigger circle touch at a single point called A. Alright, now then. Euclid first says, I want you to find the center of the bigger circle and then the center of the smaller circle. Well, it just so happens that the center of the bigger circle is at point F, and the center of the smaller circle is at point G. And then Euclid has you draw a couple of lines. He has you draw a line from F through G to point A, and a line from F to point H. Okay? Now, Euclid says that if you were to draw a line from point F to point G, and you were to extend it out all the way to A, that this would be the only way that F and G would be connected, is it would go all the way through to point A. Anyway, he says, what if we said that we could touch F and G together and we could draw a line that does not meet a point A? So, we're going to create a fake letter G. Now, this letter G is supposed to be the center of the smaller circle. So, we're going to create a fake letter G. And we're going to draw a line from point F to point G all the way up to H. And it'll pass through point D. Alright, now, it just so happens that the length of AG, right here, AG, plus GF is greater than the length of FA. Alright, now, if we were to subtract and hang on just a second here. Now, first of all, you have to keep in mind that the length of FA and the length of FH are exactly the same. And if we were to subtract the length of GF from FA and also from FH, then we could say that AG is greater in size than GH. Okay, so AG here would be greater in size than GH, which of course already you're seeing that's impossible. And then we go on to say that AG, here's AG, and GD are equal in size, and we already know that's not true. And we would have to say that because point G being the center of the smaller circle, that would mean that the line from GA and GD would be exactly the same size, because already I have a circle are equal. Then we go on to say that the length of GD and the length of GD here would be greater than the length of GH, and obviously you can see that's not true. So in the end, there's only one way that a line from point G to point from point G to point F could ever be drawn, and that is if it started at point F, went through point G, and met at a point A, which is what Euclid was trying to prove in the first place. Alright, I will tell you more in a future video, so stay tuned.